Let us see now construction of 3:8 decoder. The 3:8 decoder will have 3 inputs and 8 outputs. This is the function table for a 3:8 decoder. You can see here that when inputs are 0, 0, 0, then the zeroth output D0 is 1, or you can say it is enabled, and remaining outputs are disabled, that are 0. When input is 0, 0, 1, then the D1 output is enabled, whereas the other outputs are disabled. So for 0, 1, 0, D2 is enabled. For 0, 1, 1, D3 is 1, rest are 0. For 1, 0, 0, D4 is 1, rest of the outputs are 0. For 1, 0, 1, D5 is 1, rest of the outputs are 0. For 1, 0, 0, D6 is 1, rest of the outputs are 0, and 1 for the input 1, 1, 1. The D7 output is 1, while rest of the outputs are 0. So this is the function table for the 3:8 decoder. Now let us see how the construction of 3:8 decoder can be achieved. The 3:8 decoder can be constructed by using 8 AND gates, each with 3 inputs. So we are using here 8 AND gates, and to each of the AND gate the inputs are coming from X, Y and Z, either X, Y, Z or X bar, Y bar and Z bar. Okay. So for the functioning of this particular circuit, to verify the functioning of this particular circuit, let us consider some input. For example, we have selected this input 0, 1, 1. Okay, so XYZ, when XYZ input is 0, 1, 1, then in that case what will happen? The outputs of this particular inverters will be uh, 0, 0, 1 in this fashion respectively. Okay, then if you trace these zeros and ones to each of these particular this XYZ inputs to each of these, then you will find that only for this particular AND gates, only out of this particular 8 AND gates, only for this particular AND gate, all the inputs are 1, 1, 1. All the 3 inputs are 1, 1, 1. Okay. Whereas for rest of the AND gates, at least one of the input is 0. So as a result of this, what happens, because all the inputs for this AND gate are 1, so its output will naturally be 1, and output of the remaining AND gates will be 0. Okay, so we get for D3 the output to be 1, and for the remaining outputs they are 0. So this we can verify with the other inputs also, and you will find that the output is as shown in the function table. Now let us consider this particular decoder with enable input. It is a 2:4 decoder with enable inputs. Its function table is like this. There are 2 inputs A and B, and 4 output D0, D1, D2 and D3. Okay. So here A and B uh, will be effective if the input E is enabled. So E input, when it is 0, so it is active low, the enable input is active low. That means when E is 0, the decoder is enabled. When E is 1, the decoder is disabled. In the similar fashion, here the outputs, if you see the outputs, the normal state of the output is 1, whereas when the output is enabled, then it is 0. Okay, the selected output is 0. So here we can say that this particular decoder has active low output, that is the output which is active, it is 0. So here when the enable input is 1, irrespective of A and B, the none of the output is active. Okay, so all outputs they are 1. That means none of the output is active. Whereas if enable input is 0, then out of D0, D1, D2 or D3, any one of the output will be active. Okay, so here you can see the functioning of this particular decoder. When E is 1, then its output, the output of the inverter, it will be 0. So as it is 0, so the input, one of the input to all the NAND gates, these are the NAND gates, so the input is 0, one of the input is 0, and from the truth table of the NAND gate, if any one of the input to the NAND gate is 0, its output is 1. So output of all the NAND gates, it will be 1. So we get this. Then if E is 0, then this particular output of this inverter will be 1, and that is why all these NAND gates will have this particular inputs as 1. Now the output of these particular NAND gates will now depend on what are A0 and A1. So if A and B, what are A and B? So if A and B are 0 0, if A and B are 0 0, then you can see here that uh, this particular uh, inputs, these two particular inputs of the NAND gate, they are 1 1, and this enable, the line coming from enable, it is already 1. So all the three inputs to this particular NAND gate are 1, so the output is 0. Okay, whereas for rest of the three AND gate, you will find that either one of the input is 0, and if any one of the input is 0, the output is 1 for the NAND gate. So that is why the rest of the NAND gate will produce 1 output, whereas the output of the first NAND gate will be 0. So that is D0 is 0. Okay, in the similar fashion, we can verify that when A and B are 0 1, then in that case the D1 output will be 0, because all the three inputs of the second NAND gate are 1 1 1. Okay, for the next input AB 1 0, the all the three inputs of the third NAND gate are 1, so its output will be 0, while for rest of the NAND gates at least one of the input is 0, so its output is 1. And finally for this one, the third NAND gate will be having the inputs 1 1 1, so its output will be 0, while rest of the NAND gates will have the output 1. Okay, so this is how we can construct a 2 is to 4 decoder with enable input.